Number 2. The staples inside a stapler are kept in place by a spring with a relaxed length of 0.115 meters. If the spring constant is 51.0 newtons per meter, how much elastic potential energy is stored in the spring when its length is 0.150 meters? So, some things that I know. Spring constant. Okay, where is it? Right there. This is something that is inherent to each spring based on its structure, based on its material type, how it's made. And so this is going to be unique to each spring. We also have the value for X. Remember, this is a difference. So I'm going to take my 0.150 and I'm going to subtract 0.115 to give me an overall change of 0.035 meters. And again, the equation I'm going to use here, potential energy is equal to 1/2 K, spring constant. And then X here is, again, it's the distance that the spring is actually being deformed. And don't forget the square, because that'll mess you up big time. Now, I am being asked to solve for elastic potential energy, so the equation is already set up to solve for that term. So I'm ready to plug and chug directly from the problem. So 1/2, my K value is 51.0 newtons per meter. I had to calculate the X value, right, because it's the resting length, the difference between the resting length and the deformed length. And so my difference is, where is it? I lost it already. 0.035 meters. Don't forget the square. And my calculator says with two significant figures, right? Because there's two significant figures here. Even though there are 3 here and 3 here, that smaller number is going to require me to report my... Actually, no, take it back. That's 3. We're looking at something else? No, so it should be 3. Oh, no, okay, so, yeah, sorry. In this subtraction, as a result, I only have a value with 2 significant figures, and so this is actually limiting me. So it is 2 significant figures, but not because of the question, but because we had to do addition subtraction right here. That changed the number of sig figs to simply 2. So I'm going to report an answer of 3.1 times 10 to the second power joules.